This is a video on balancing combustion reactions. Combustion occurs between hydrocarbon and oxygen. With a little bit of heat added, it produces carbon dioxide and water. The only variable in the equation is the hydrocarbon, because this can be 3 carbons or 2 carbons or even 1 carbon with a number of varying number of hydrogens. So the hydrocarbon is the variable here, but oxygen will always react with the hydrocarbon. At a little bit of heat, you'll produce carbon dioxide and water. Here's an example. C3H8 plus O2. Add a little bit of heat, and you'll produce CO2 plus H2O. And now we practice balancing combustion reactions. So the first thing you have to do is identify it as being combustion. Hydrocarbon, in this case C3H8 plus oxygen in the presence of heat produces carbon dioxide and water. So we get to identify the elements involved here. We have a carbon, hydrogen, and oxygen. So we always have this CHO, carbon, hydrogen, and oxygen, when we're talking about combustion reactions. And now we just have to conserve matter. It is a law, the law of conservation of matter, where the number of atoms, the amount of matter on the left side or in the reactants will also equal the amount of matter in the right side in the products. And at time, some of this will be dissipated as heat. Okay. So we have 3 carbons in the reactants, and we start with 1 carbon in the products. We have 8 hydrogens in the reactants, and we begin with 2 hydrogens in the products. We have 2 oxygens in the reactants, and we have 2 plus 1, 3 oxygens in the products. And we have to get this balanced. So we have 3 carbons here, so we're going to add 3 carbons there naturally. We have 8 carbons. You always want to start left and go right. So we have 8 hydrogens to begin with in the reactants. So to make 8 over here, we would add a 4. And then we have to add up the number of oxygens. So this changed to 8 hydrogens. And now we have to add up the number of oxygens on the right and make sure the left side also has that number of oxygen atoms total. So we have 3 times 2 is 6 oxygen atoms, so 6 O's, plus 4 times 1 is 4 O's, for a total of 10 oxygens in the reactants, okay? Or excuse me, in the products. So how are we going to get 10 over here? Well, we can simply put a 5 in front of that oxygen, and 5 times 2 makes that 10. And we can go back and we can make sure we have 3 carbons and 3 carbons, 8 hydrogens and 8 hydrogens, 10 oxygens and 10 oxygens. So we have a balanced equation, and matter has been conserved. Let's do another example for a combustion reaction. Okay, let's take ethanol, for example. Ethanol is C2H5OH. And that is our hydrocarbon. Put it in the presence of, or react it with oxygen, O2, which is a gas. This ethanol, because it's an alcohol, is going to be a liquid state of matter to begin. And we're going to add it to oxygen gas, put it in the presence of a little bit of heat, and produce CO2 plus H2O. And here's our reaction. So let's clean this up a little bit. C2H5OH as a liquid is going to react with oxygen as a gas, put it in the presence of some heat, and we will produce CO2 and water, typically in the form of a gas, and water vapor in the form of a gas as well. So let's go ahead and let's balance the equation using our T-chart. Okay, so we have CHO, carbon, hydrogen, and oxygen because it's a combustion reaction. And we start with, let's just use this formula down here. This one got a little messy. So we use this formula here. We have two C's to begin. We have one C in the product. We have 5 hydrogens, and we have 2 hydrogens in the product. Pardon me, we have 5 plus 1 hydrogen, so we actually begin with 6 hydrogen in the reactants, 2 in the products. And we begin with 1, 2, 3 oxygens, and 1, 2, 3 oxygens in the product. So let's go ahead and balance that. So carbon, we have 2 carbons here, we have 2 carbons here. We have 6 hydrogens here. We have 2 hydrogens here, so we can add a 3 to make it 6 over here. And let's see what it did to the oxygen in the products. So now we have 2 times 2, which is 4 oxygen, 4 oxygen plus 3 times 1, which is 3 oxygen equals 7. 7's an odd number, so it's going to be really hard to turn this number into a 7, except we have 1 more oxygen in the reactants. So if we make this number a total of 6 by adding a coefficient of 3, then we have 3 times 2, which is 6, plus 1 more, which is 7. And we should have 7 oxygen in the reactants is equal to 7 oxygens in the product. Have we conserved matter? Yes, we have. We're going to do one more example of a combustion reaction. We're going to complete the combustion of octane C8H18 liquid. Okay, so you can see that we're going to do a combustion reaction. This is the type of reaction. And here is the only variable in the reaction, which is the octane, which is simply, as we've learned, 1, 2, 3, 4, 5, 6, 7, 8 carbons. Each carbon making 4 bonds. So if this carbon already has 1, then it's going to require 1, 2, 3 H's. And this is an H, and this is an H. So we have 8 carbons and 18 hydrogens. And you'll notice that in hydrocarbons, the number of carbons is given, so 8 carbons, therefore oct is the prefix, and then you can double the number of carbons and add 2, so double 8 and add 2 more to figure out mathematically, without drawing out the entire structure, to figure out how many hydrogens would be connected. So C8H18 in this case. Okay, so to write it as a combustion formula, you would write C8H18 as a liquid. It reacts with oxygen gas, which is a diatom, gas at room temperature, add a little bit of heat, produce CO2 plus H2O, and these are both vapors or gas, just like oxygen. Okay, so now let's go ahead and balance it. We still have C, H, O. These are the only elements that appear in this reaction. And we break them into their elements because none of these molecules appear on the left and the right side, the reactant and the product side. So we have to break them into their elements instead of keeping them as molecules or compounds. So we begin with 8 reactants on the left side of the equation, carbon reactants, and we have 1 in the products. We have 18 hydrogens. We have 2 hydrogens in the product. We have 2 oxygen, and we have 2 plus 1, 3 oxygen in the product. So in order to get 8 carbons, we would put 8 as a coefficient in front of CO2. And then we need 18 hydrogens, so we would put a 9 here to make a total of 18. And now let's figure out how many oxygens we have. So we have 8 oxygens plus, or times 2, plus 9 times 1 oxygens. We have 16 plus 9 equals 25 oxygens in the product. Okay, how are we going to get 25 here? Well, 25 is an odd number, and it does not go evenly into 2, and this ratio needs to be a whole number. So instead of putting 12.5 to get 25, what we do instead is we just double it. Okay, so we double 25 and make it an even number, 50. So we want to get a total of 50 over here. So we had 25 as the coefficient, okay? And because we doubled that, we're going to have to double this, and let's see what it does. So now we have 25 here, but now we have 16 carbons on the right side. To get 16 in the reactants, we'd have to put it 2 in front of the C8H18. So we have 2 as the coefficient. So now we have 16 here. And we have 2 times 18. So we have 36 hydrogen. And now we have 18 times 2 hydrogen, which is 36. And we have conserved matter. So our coefficients are 2, 25, 16, and 18. And that's how you balance combustion reactions.